Good morning. Our today's discussion is about oxidation of carbonyl compounds. Oxidation of carbonyl compounds, that is oxidation of aldehydes and oxidation of ketones. Now what is oxidation? Oxidation, it is nothing but addition of oxygen or it is removal of hydrogen. This concept already we studied it in first year. So oxidation means addition of oxygen or it is removal of hydrogen. For oxidation we need oxidizing agents. We need what? We need oxidizing agents. Now let us discuss the oxidation of aldehydes and ketones. See, aldehydes differs from ketones. Aldehydes differs from ketones in their oxidation reactions. Aldehydes differs from ketones in their oxidation reactions. Means oxidation of aldehyde, it is not similar when it is compared with oxidation of ketones. So there is a difference in oxidation of aldehyde and oxidation of ketones. So aldehydes differ in their oxidation. See, aldehyde, formula of aldehyde we know, that is RCHO. When it is subjected to oxidation means addition of oxygen. Okay. So aldehydes readily undergo oxidation in the presence of commonly used oxidizing agents, that is HNO3, nitric acid, KMNO4, potassium permanganate, K2Cr2O7, potassium dichromate. So these are commonly used oxidizing agents or stronger oxidizing agents. So in the presence of commonly used oxidizing agents like nitric acid, potassium permanganate, potassium dichromate, these aldehydes readily undergo oxidation forming carboxylic acid. Forming carboxylic acid, that is carboxylic acid containing same number of carbon atom as that of what? As that of parent aldehyde. So formed carboxylic acid contains same number of what? Same number of carbon atoms as that of parent aldehyde. So aldehyde undergoes oxidation readily, forming carboxylic acid with what? With same number of carbon atom. So we can see here oxidation of aldehyde just involves what? It just involves addition of oxygen. So one extra oxygen it is added, thereby CHO it is converted to COOH. Okay. See, even mild oxidizing agents, even mild oxidizing agents. Mild means neither it is strong nor it is weak. Example for mild oxidizing agents: one is Tollens reagent, mild oxidizing agent, that is Tollens reagent. Other one, it is named as Felling's reagent. So Tollens reagent, Felling's reagent, they are examples for mild oxidizing agents. So even in the presence of mild oxidizing agents, these aldehydes readily undergo oxidation. Forming carboxylic acid, that is RCOOH. So aldehydes undergoes oxidation in the presence of stronger oxidizing agents as well as in the presence of milder oxidizing agent. This is because oxidation of aldehyde just involves what? Just involves addition of extra one oxygen forming carboxylic acid. But what about ketones? Say, ketones cannot undergo oxidation reaction readily or easily. So oxidation of ketones, it is difficult. So oxidation of ketones, it is taking place Under what? Under vigorous conditions. Oxidation of ketones, it is taking place under what? Under vigorous condition. What is that vigorous condition? Those conditions are one is oxidizing agent must be stronger oxidizing agent only. Other one, elevated temperatures. So, oxidation of ketone, it is taking place under what? Under vigorous condition. Vigorous condition means oxidizing agent. So, taken oxidizing agent must be, it should be a stronger oxidizing agent. Temperature must be higher temperature. Elevated means increased temperature. So, temperature must be very high. Oxidizing agent must be stronger oxidizing agent. So, why do we need increased temperature for the oxidation of ketones? For the oxidation of ketones, why do we need increased temperature? Why temperature must be very high for the oxidation of ketones? This is because during the oxidation of ketones, during the oxidation of ketones, cleavage of carbon-carbon bond takes place. Cleavage of what? Carbon-carbon bond takes place. So, for the cleavage of carbon-carbon bond, energy required, it is very high. Required energy is what? It is very high. So, we have to take elevated temperature. Elevated temperature. So, oxidation, it is occurring at what? At elevated temperature and also in the presence of stronger oxidizing agent. So, elevated temperature, it is, why it is required? It is to cleave carbon-carbon bond. To cleave what? Carbon-carbon bond, and formed product will be mixture of carboxylic acid. What about aldehyde? Aldehyde gives only one carboxylic acid. Ketones upon oxidation produces mixture of carboxylic acids containing lesser number of carbon atom than that of parent ketone. So, formed product, that is formed carboxylic acids, they are having what? They are having lesser number of carbon atoms when it is compared with what? With the parent compound, that is parent ketone. Let us take one example, general example. R CH2 C double bond O CH2, this group I will take it as R dash. So, it is R CH2 C double bond O CH2 R dash. Now, this ketone, it is subjected to what? Subjected to oxidation. Subjected to oxidation by adding stronger oxidizing agent and higher temperature or elevated temperature. So, oxidation, it is taking place here. Okay, so oxidation. Oh, I'll number these carbon atoms. This is carbon number 1, second one. This is the third carbon atom. Totally, we can see 3 carbon atoms. Now, we know that during the oxidation of ketones, cleavage of carbon-carbon bond takes place. So, carbon-carbon bond cleavage can take place at C1, C2. So, cleavage of C1, C2 can occur or C2, C3. So, bond cleavage can take place here or in this position. So, let us consider C1, C2. Cleavage of carbon-carbon bond at C1, C2, this bond. Suppose cleavage, if it is occurring here, then we will get 2 different carboxylic acid. This part we have to consider it as carboxylic acid. Left hand side, right hand side will form another carboxylic acid. On the left hand side, we are having what? We are having RCH2. So, what I have to write? I have to write RCH2, I will take it as COOH. Carboxylic acid, correct? So, there is only one carbon atom here. So, this is also having what? Having only one carbon atom. This one also forms carboxylic acid with 2 carbon atoms. So, I will write COOH 2 carbon atoms, correct. So, 1 carbon atom already I wrote. I have tried one more, then it is R dash. Then it is what? Then it is R dash. So, it is R dash CH2 COOH. COOH. Look at the number of carbon atom, then write the product. So, first part, this one, there is only 1 carbon atom. So, I wrote COH. So, 1 carbon atom, remaining group it is R. On the right hand side I can see 2 carbon atoms. So, I wrote COH first carbon, this is second carbon. So, we will get 2 different carboxylic acids, and this product, it is due to the cleavage of which bond? Cleavage of C1C2 bond. Cleavage of what? C1C2 bond. Let us take one more. See, bond cleavage can take place at this position also. At this position. So, suppose if it is occurring at this position, then this one I have to consider it as carboxylic acid. This is another carboxylic acid. So, this right hand side contains only 1 carbon, correct. So, I will write COH. So, carbon atom it is already over, 1 carbon atom, write R dash. Okay, plus one more. This is having 2 carbon atoms. So, it is COOH, first carbon, second carbon, then it is R. Then it is R. So, it is R CH2 COOH. So, this is due to the cleavage of C2C3 bond. So, this product it is obtained due to the cleavage of C2C3 bond. So, this is about oxidation of ketones. Oxidation of ketones. So, oxidation of ketone involves cleavage of carbon bond at a higher temperature. So, cleavage it is occurring at a higher temperature, forming mixture of carboxylic acids having lesser number of carbon atom than that of parent ketone. This is the parent ketone. So, number of carbon atoms will be reduced. Number of carbon atoms will be reduced during what? During the oxidation. This is due to cleavage of what? Carbon bond. Next one, under oxidation, see tests used to distinguish aldehydes and ketones. So, tests used to distinguish aldehydes and ketones. See, for this purpose, we are using mild oxidizing agents, that is Tollens reagent and Fillings reagent. So, for Tollens reagent and Fillings reagent, they are examples for mild oxidizing agents. In the presence of mild oxidizing agent, only aldehyde undergoes oxidation, whereas ketone cannot undergo oxidation. So, in the presence of mild oxidizing agents, aldehydes readily undergo oxidation, ketones do not respond. Ketones do not respond in the presence of what? In the presence of mild oxidizing agents. So, first test, there are 2 different tests. Name of the test, it is Tollens test. This is the first one. First test, which is used to distinguish aldehydes from ketones. See, in Tollens test, reagent used is Tollens reagent. reagent used in tolerance test, that reagent it is called as what? Tolerance reagent. Now what is tolerance reagent? For 1 mark they can ask, say tolerance reagent means freshly prepared ammonical silver nitrate solution. So what is tolerance reagent? Freshly prepared ammonical silver nitrate solution. Ammonical silver nitrate solution, it is called as tolerance reagent. Tolerance reagent. So how do we prepare tolerance reagent? A drop of silver nitrate treated with sodium hydroxide. Drop of silver nitrate treated with sodium hydroxide. This is Ag plus NO3 minus Na plus OH minus. So formed product will be AgOH along with NaNO3. AgOH means silver hydroxide along with sodium nitrate. Silver hydroxide along with sodium nitrate. Now this silver hydroxide readily loses water like this. AgOH plus AgOH. So water molecule will be eliminated forming Ag2O. So it readily loses water forming silver oxide. So silver nitrate treated with sodium hydroxide forms silver hydroxide along with sodium nitrate. Silver hydroxide readily loses water forming silver oxide. So this silver oxide, it is dissolved by adding, or this precipitate, it is dissolved. We'll get a precipitate here. So brown colored precipitate. This brown colored precipitate, it is dissolved by adding ammonium hydroxide. Thereby we'll get tolerance reagent. Formula of tolerance reagent, it is like this. It is Ag NH3 twice plus OH minus. This is tolerance reagent. A complex will be formed, complex of silver, that is Ag NH3 twice positive part plus OH minus. So this is the preparation of tolerance reagent. So tolerance reagent, that is freshly prepared ammonical silver nitrate solution. How do we prepare tolerance reagent? A drop of silver nitrate solution treated with sodium hydroxide. Precipitate is obtained. Dissolve that precipitate by adding ammonium hydroxide. Formation of tolerance reagent occurs. Now we can write the equation. We know that this test, it is answered only by aldehyde, correct? Because we are using mild oxidizing agent. Okay, aldehyde treated with tolerance reagent, that is Ag NH3 twice plus OH minus plus what? OH minus. So this is tolerance reagent. Reaction, it is taking place in, we are adding ammonium hydroxide during the preparation of tolerance reagent. So hydroxide is there, OH minus ion. So reaction, it is taking place in alkaline medium or in basic medium, not in basic medium. So tolerance reagent, what is this? This is oxidizing agent. What is this? Oxidizing agent. It should oxidize aldehyde. So aldehyde undergoes oxidation in the presence of tolerance reagent. Aldehyde undergoes oxidation forming carboxylic acid, that is RCOOH. RCOOH, or you can write it in ionic form also. It is RCOO minus, RCOO minus. This is ion of carboxylic acid. It is named as carboxylate anion. Carboxylate anion. So aldehyde undergoes oxidation forming carboxylic acid or carboxylate anion. So during the reaction, see here, silver, it is in +1 state. Silver, it is in +1 state. We can calculate it. See Ag, NH3 twice. Here there is plus charge. So silver we don't know, it is X. Ammonia, it is 0 into 2 equal to +1. X equal to +1. So silver, it is in +1 state. Or oxidation state of silver, it is +1. It is an oxidizing agent. Oxidizing agent always undergoes reduction, that is decrease in oxidation number. So this silver from +1 state, it will be reduced to Ag, reduced to Ag. Here oxidation number, it is 0. It is in elemental form. Along with Ag, ammonia molecules are liberated. Ammonia molecules are liberated. One more byproduct, that is water. That is what? That is water. So aldehyde undergoes oxidation forming carboxylic acid. Tolerance reagent undergoes reduction. Forming silver. Forming what? Forming silver. And during the reaction, this silver will be deposited on the walls of the test tube. On what? On the walls of the test tube. As a result, a bright means shining silver mirror. Since it shines, we call it as mirror. Okay. So silver will be deposited on the sides of the test tube. So, or I can say a bright silver mirror is seen on the walls of the test tube. So this reaction we call it as tolerance test. Reagent used is tolerance reagent. So what is that test? Aldehyde when it is warmed. Aldehyde when it is warmed with tolerance reagent. Aldehyde when it is warmed with tolerance reagent. Aldehyde undergoes oxidation forming carboxylic acid. Whereas tolerance reagent being an oxidizing agent undergoes reduction, that is from +1 state to 0, +1 to 0, and this silver will be formed inside the test tube, or it is deposited on the sides of the test tube and it will shine like a mirror. Therefore we call it as a bright silver mirror is produced in the test tube. Okay, so this test, it is called as tolerance reagent. We can balance this. Here there is one molecule, here there is 2, 3. It is 1, 2, 3. 1, 2, 3. We can see 2 Ag molecules here. 2 Ag, NH3, 2 into 2, it is 4. 4 NH3. Water molecules totally 2 molecules of water. 2 molecules of water. So this is about tolerance test, and this test, it is answered only by aldehyde, it is not answered by ketones. Next one, Fillings test. Fillings test. Say this test, it is also used to distinguish aldehydes from ketones. Aldehydes from ketones. In this test, we use a reagent. That reagent, it is called Fillings reagent. Reagent, it is named as what? Fillings reagent. Fillings reagent. Now what is this Fillings reagent? See, Fillings reagent, it is made up of 2 solutions, or it comprises of 2 solutions. So Fillings reagent, it is a mixture of 2 solutions. One is filling solution A, filling solution A. Other one is filling solution B. So Filling's reagent means it is a mixture of filling solution A and filling solution B. Now what is filling solution A? Aqueous CuSO4 copper sulfate solution. Aqueous copper sulfate solution, it is named as filling solution A. What is filling solution B? Filling solution B means alkaline solution containing sodium, potassium tartarate. So alkaline solution containing sodium, potassium tartarate. This salt it is called Rochelle salt. This salt it is called as what? Rochelle salt or Rochelle salt. So Filling's reagent, it is made up of two different solutions, filling solution A and filling solution B. Filling solution A means aqueous, that is copper sulfate dissolved in water, aqueous copper sulfate solution. Filling solution B means it is alkaline solution containing sodium, potassium tartarate, a complex salt. So sodium potassium tartarate, it is also called by the name Rochelle's salt. So in order to obtain Filling's reagent, before conducting the test, what we have to do is we have to mix these two solutions. So suppose if you want Filling's reagent for the test, mix these two solutions in equal amounts before the test. So mix solution A and solution B in equal amounts. When we mix these two solutions in equal amounts, we will obtain what? We will obtain Filling's reagent, and this reagent can be used for the test, Filling's test. Let us write the equation. Say aldehyde. Why it is aldehyde? Because Filling's test it is answered only by aldehyde. It is not answered by ketones. Okay, aldehyde treated with Filling's reagent. Filling's reagent means copper sulfate, correct? So in copper sulfate, copper it is in +2 state. So write Cu2 plus ions. Alkaline medium. Alkaline means OH minus. It is sufficient if we write like this: Cu2 plus what? Plus OH minus. What is this? This is Filling's reagent, or it is oxidizing agent. Okay. So in the presence of oxidizing agent, aldehyde undergoes oxidation forming carboxylic acid. That is carboxylate anion or RCOH, carboxylic acid. Cu2 plus being an oxidizing agent undergoes reduction forming Cu2O. See, in Cu2O, copper it is in +1 state. So +2 to +1, it is reduction. So copper +2 in +2 state, it is reduced to +1 state. This is a precipitate, a reddish brown precipitate of what is Cu2O? It is cuprous oxide. Reddish brown precipitate of cuprous oxide. So aldehyde, when it is heated with Filling's reagent, a reddish brown precipitate of cuprous oxide is obtained along with water molecule. Along with water molecule, we can balance this equation. Cu2. So it is 2Cu. It is 5 OH minus 5 hydrogen plus 1, 6 hydrogens. So it is 3 into 2, it is 6. So aldehyde heated with Filling's reagent produces reddish brown precipitate of cuprous oxide. So this confirms the presence of aldehyde. Whereas if we heat ketone with Filling's reagent, no reddish brown precipitate is seen, or formation of reddish brown precipitate will not take place. So tolerance test and Filling's test, these two tests, they are used to distinguish aldehydes and ketones and this test it is answered only by aldehydes, it is not answered by ketones, not answered by ketones. Next one, under oxidation, oxidation of methyl ketones. Oxidation of methyl ketones by haloform. By haloform reaction. Important. Oxidation of what? Oxidation of methyl ketones by haloform reaction. See, haloform reaction, see, before explaining this reaction, what is haloform? See, we came across chloroform. Formula of chloroform, it is CHCl3. CHCl3. Bromoform means it is CHBr3. Iodoform means it is CHI3. CHI3. So CHCl3 is chloroform, CHBr3 bromoform, CHI3, what is this? Iodoform, or in general it is CHX3. CHX3. So CHX3, it is named as haloform. Haloform. How it is obtained? Haloform. See, haloform reaction, it is answered only by methyl ketones, or this reaction can be seen only in the case of methyl ketones. It is answered only by methyl ketones. How do we write this methyl ketone? Methyl means CH3, ketone means C double bond O. So this group must be there in the compound, given compound. So CH3 must be directly bonded to C double bond O. Suppose if I take formaldehyde, this is the formula of formaldehyde, and this formaldehyde does not answer haloform reaction. Does not answer haloform reaction because it does not contain any methyl group. Methyl group directly bonded to carbonyl group. We can take acetaldehyde, CH3, C double bond O, single bond H. See, this compound answers haloform reaction because it contains one methyl group directly bonded to carbonyl group. Directly bonded to carbonyl group. So, compounds containing at least one methyl group. Compounds containing at least one methyl group directly bonded to carbonyl group. Directly bonded to carbonyl group undergo oxidation, or methyl ketones, I can say. Methyl ketones undergo oxidation in the presence of oxidizing agent. In the presence of what? Oxidizing agent. That oxidizing agent is sodium hypohalite. Sodium hypohalite. Formula of sodium hypohalite, it is NaOX. So NaOX means sodium hypohalite, and this is the oxidizing agent used in haloform reaction. Oxidizing agent used in haloform reaction. So methyl ketones, they are undergoing oxidation in the presence of oxidizing agent, that is sodium hypohalite, to form what? To form haloform. I will write the equation. Say, ketonic group, it is directly bonded to methyl group. This is methyl ketone. Methyl ketone, while writing the general equation, write R, capital letter R. It is R, C double bond O, CH3. This is methyl ketone. It is subjected to oxidation by adding oxidizing agent, that is sodium hypohalite. Sodium hypohalite. So oxidation of this carbonyl compound gives out, whether it is aldehyde or ketone, they will undergo oxidation forming carboxylic acid only. So, this is a carbonyl compound, ketonic group. This compound contains ketonic group, or it is a keto compound, correct? And this compound undergoes oxidation forming carboxylic acid, that is salt of carboxylic acid, salt of carboxylic acid. What we have to do is, see this methyl group, we should remember this, methyl group during the reaction it is converted to haloform, So, for haloform we need carbon, hydrogen and halogen, okay. So, this much. So, methyl group it is converted to haloform, that is CHX3, write the remaining group, that is our C double bond ONA, it is our COONA. What is RCONA? This is sodium salt of carboxylic acid, sodium salt of carboxylic acid. So, methyl ketones undergo oxidation in the presence of sodium hypohalide forming sodium salt of carboxylic acid containing one carbon atom less. Why one carbon atom less? Because one carbon atom less means that is methyl group, it is removed in the form of what? It is removed in the form of haloform, that is CHX3. We can write some examples for this. CH3, C double bond O, single bond H. Name of this compound is acetaldehyde. When it is subjected to oxidation by adding NaOCl. What is this NaOCl? NaOCl means sodium hypochlorite. Te, hypochlorite. Okay. So, first convert this methyl group into what? Into haloform. Halogen present here, that is chlorine. So, product formed will be CHCl3. Write the byproduct, that is H, C double bond ONA, it is HCOONA. So, CHCl3 means chloroform. We can take one more example. I will take aromatic aldehyde, benzaldehyde. Sorry, not benzaldehyde. Benzaldehyde does not answer this test because benzaldehyde does not contain any methyl group. I can take aromatic ketone, acetophenone. Acetophenone subjected to oxidation by adding sodium hypoiodide, or in the place of sodium hypoiodide we can add this mixture also, sodium hydroxide along with iodine. So, iodine crystals, sodium hydroxide and iodine crystals can also be used in the place of sodium hypoiodide. This reaction it is called iodoform test because formed product it is iodoform. What is this? Iodoform test. Iodoform means preparing iodoform. So, aromatic ketone, that is acetophenone, subjected to oxidation by adding sodium hypoiodide or adding mixture of sodium hydroxide and iodine. During the oxidation, methyl group it will be converted to what? Converted to iodoform, that is CHI3. CHI3 means iodoform. Along with the iodoform, we will get one more product, that is benzene ring, C double bond O, ONA, or it is COONA, sodium salt of benzoic acid. This is sodium salt of formic acid. What is this? Sodium salt of benzoic acid. It is named as sodium benzoate. This is sodium formate. Okay, so iodoform test. or haloform test, it is answered only by methyl ketones. That is very important. This test it is seen, or this reaction it is seen only in methyl ketone. Methyl ketone means methyl group directly bonded to ketonic group C double bond O or carbonyl group, and this type of compound when it is subjected to oxidation by adding oxidizing agents, that is sodium hypohalide, will get sodium salt of carboxylic acid containing one carbon atom less. This is because during the oxidation one of the carbon, that is methyl group, it will be converted to haloform. Under haloform, this is very important, iodoform test. In the case of iodoform test, methyl ketones, they are subjected to oxidation by adding sodium hypoiodide, or we can use sodium hydroxide along with iodine. Iodoform will be formed along with sodium benzoate. See, iodoform test or haloform test. What is the use of haloform test? Iodoform test, this test can be used to detect the presence of CH3 double bond O. By using iodoform test, we can detect the presence of CH3CO group. So during the iodoform reaction, if we obtain yellow crystals of iodoform, then this indicates what? The presence of CH3CO. Without possessing CH3CO group, we can't see iodoform, yellow crystals of iodoform. So iodoform reaction, it is used to detect the presence of CH3CO group in the given organic compound, or it can also be used to detect the presence of secondary alcoholic group. This is secondary alcoholic group. CHOH means secondary alcohol, CH2OH means primary alcohol. So secondary alcoholic group can also be detected by using iodoform test, because see, secondary alcohol in the presence of sodium hypoiodide or in the presence of oxidizing agent, secondary alcohol undergoes oxidation forming ketone, that is CH3 double bond O. So iodoform reaction, it is used to detect either the presence of CH3CO group, or we can also use this test for the detection of secondary alcoholic group, CH3CHOH group. This is because secondary alcohol upon oxidation produces same thing, CH3CO group. This is the first one. Second one, methanol and ethanol, both are primary alcoholic groups. Formula of methanol, it is CH3OH. Formula of ethanol, it is CH3CH2OH. See, when it is subjected to iodoform reaction, that is, we have to add oxidizing agent NaOI. In the presence of oxidizing agent, this alcohol, primary alcohol, undergoes oxidation forming aldehyde. Because both are primary alcohols. Primary alcohols upon oxidation form aldehyde. Secondary alcohols upon oxidation forms ketone. Now this is methyl alcohol, which contains only one carbon atom. So we will get aldehyde containing one carbon, that is HCHO, formaldehyde. Whereas ethyl alcohol or ethanol, in the presence of oxidizing agent, forms an aldehyde containing two carbon atoms. Containing two carbon atoms, that is CH3CHO. CH3CHO can be written like this. Correct. So we can see here Methyl group, there is a methyl group directly bonded to carbonyl group. What about formaldehyde? It is H, C double bond OH. There is no methyl group directly bonded to carbonyl group. So, methanol does not answer haloform reaction. Ethanol answers haloform reaction. Answers what? Haloform or iodoform reaction. This is because methanol upon oxidation produces formaldehyde, which does not contain any methyl group directly bonded to carbonyl group, whereas ethanol upon oxidation produces acetaldehyde. So, in acetaldehyde there is what? There is methyl group directly bonded to carbonyl group. So, methanol and ethanol can be distinguished by using iodoform test, and also we can distinguish ethanol and propanol. So, this pair of compounds can also be distinguished by using iodoform reaction. One more example, 1 propanol and 2 propanol. So, ethanol and methanol, ethanol and propanol, 1 propanol and 2 propanol. So, these pair of compounds can also be distinguished by using what? By using haloform reaction. Haloform reaction. One more point I want to say. See, suppose if there is a carbon-carbon double bond in the given compound like this. Say this is a methyl ketone. We can see methyl group directly bonded to carbonyl group, and this methyl ketone possesses carbon-carbon double bond. Suppose this type of compound, if it is subjected to oxidation by adding oxidizing agent, that is sodium hypoiodide, we know that during the oxidation methyl group, which is directly bonded to carbonyl group, it will be converted to haloform, that is CHI3. Along with this haloform, sodium salt will be formed, that is C double bond C. Here there is hydrogen, other one it is CH3. Then we have C double bond O, ONE. C double bond ONE. So, if there is any carbon-carbon double bond in the given methyl ketone, during the oxidation that double bond will not be disturbed. The double bond will be retained as it is, whereas methyl group, which is directly bonded to the carbonyl group, that methyl group, it will be converted to haloform. Okay, this is about haloform reaction or iodoform reaction. Thank you.